Hello everyone, my name is Guillaume. I work at AHUG Scale, a small French company specialized in software optimization. So today I will talk to you about the NSIMD library and its applications to EFISPEC3D, GROMACS, and at the end of the talk I will talk to you about SVE programming. So NSIMD is an open source library that can be found on GitHub. It abstracts NSIMD programming. We provide several APIs, a pure C API, C++ 9.8 API, up to C++20 API. So the C++20 API, for example, uses concepts. So we support the latest technologies such as ARM SVE in two ways. I will describe them later in the talk. We also support NVIDIA GPUs via C++ expression templates and SPMD programming via C++ DSL that we provide with the library. I will also talk about this later in the talk. So NSIMD allows you to write optimized code at a low development cost. This is the main goal of the library, to provide a way to write optimized code at low development cost. This increases maintainability, readability, and portability of the code. So we have inserted the NSIMD inside GROMACS. GROMACS is well known. It's a software for simulating molecular dynamics. It's very well optimized for CPUs. It uses SIMD intrinsics written by hand for each SIMD extension that GROMACS supports. So inside GROMACS, we have a directory for each SIMD backend that GROMACS supports. So what we have done is add a new backend, a new SIMD backend to GROMACS, which is nothing else than NSIMD. And so our goal is not to have better running times because GROMACS is very well optimized. So our goal is to have similar running times to show that NSIMD doesn't incur any overhead on the execution time of GROMACS. And so the execution time of GROMACS is summed up in the following graph. So you have three lines. The first one is the NSD counter of GROMACS when GROMACS is compiled without any SIMD backend. The second line is GROMACS compiled with AHUG 64 SIMD backend. It's native code. And the third line is GROMACS compiled with NSIMD, which itself is compiled using AHUG 64 backend. And so as you can see, we have the same value for the NSD counter, which means that NSIMD doesn't incur any overhead on the execution time of GROMACS. But what is interesting is that we have drastically decreased the number of lines of code in the SIMD backends of GROMACS. So if you take all the SIMD backends of GROMACS that are also supported by NSIMD, you can drop 7,000 lines of code, of native GROMACS code, and replace them with roughly 1,200 lines of code. So this means less lines of code, better maintainability, better readability, portability, and as you have seen, same performances. So we have also inserted NSIMD inside EFISPEC3D. So EFISPEC3D is a ground motion simulator. It's based on the spectral finite element method. It was developed at BRGM. It's the French Geological Survey. Its original code was written in Fortran, and no compiler is able to auto-vectorize the code well. This is due to the fact that the code uses unstructured mesh. Therefore, you have a lot of memory and direction before getting your data for doing computation. As you can see on the following graph, we have three versions of EFISPEC3D. The first version, which is the original one, is represented in gray in this graph. The second version is the same kernel but written with intrinsics. This is the blue bars in this graph. And the third version is the NSIMD version, which is the kernel written with the NSIMD NPI. And as you can see, first doing vectorization by hand, we have a speed up of 2 times, which is important. Secondly, as you can see, using handwritten intrinsics or NSIMD, we have the same running times. But as I told you, this is the same as for GROMACS. We have only one code, which can be compiled to target all the SIMD backends that NSIMD supports. Then I will end this talk about SVE programming and NSIMD. So NSIMD supports two ways of doing SVE. SVE can be done, let's say, with arm's length as a true sizeless way of doing things, which means you don't know the SVE vector size at compile time. You only know them at runtime. But GCC chose a different approach. You have to know the SIMD vector size at compile time. And you have little choice. Namely, you have the choice only between these numbers. And we provide 3 APIs for doing SVE in NSIMD. So the first API is the historical one, which is provided by the NSIMD core. That's the code that wraps intrinsics. The second API is the module of expression templates, C++ expression templates. And the third way of doing SVE is via another of our module, which is called SPMD, so single program multiple data, which allows you to write code à la CUDA. I will come at this right now. So SPMD programming is basically like CUDA programming. So NVIDIA calls it SIMT. I don't know which name is best, but on internet it seems that SPMD is more used than SIMT. So anyway, that's the same programming model as CUDA. Then this allows NSIMD to target both CPUs and GPUs. So for GPUs, the C++ DSL that we provide only translates one-to-one into a CUDA kernel. And when targeting CPUs, we emit SIMD instructions a la ISPC. So as you can see in the following example, so this is an addition of vectors. So at the top you have the CUDA kernel. So this is a very usual CUDA kernel. You take your input, you add them, and you put the result back into DST. The equivalent in this kernel in the NSIMD SPMD module is like this. So we had to respect the C++ syntax as we are a C++ DSL, so you may find the syntax a little weird. But basically the same as the above CUDA kernel. You take your input, you load the values from memory, you add them, and you put the result back into DST. And I put the main function so that you can see how to call this kernel. This is this line. And you find all the parameters that you have when you launch a standard CUDA kernel. And as I said, this C++ DSL allows NSIMD to target both CPUs and GPUs with performances. As a conclusion, as I showed you, so NSIMD allows you to have less lines of code, which means better readability, maintainability. NSIMD provides portability of your code across GPUs and CPUs. And also, as I showed you, NSIMD has no overhead for scientific and industrial code bases that do heavy computation. You can use NSIMD with trust. And you can find also GROMACS on our GitHub. You can find NSIMD also on our GitHub. And you are welcome to visit our website at ageniumscale.com. Thank you very much.